Good afternoon to all of y'all. Frictional forces act in pairs as per Newton's third law. Now we wish to see what is the total work done by a pair of frictional forces. Work is defined as the dot product of the force and the displacement of the point of application of the force. This is the basic definition of work. We have dealt with this basic definition of work in another video. You can take a look at that video to understand the significance of this definition. We will take this definition for granted, and now let us say there are two surfaces. There is a body A. This is surface 1A. We will call this as surface A. This is body A. This is surface B. We will call this as surface B. This is body B. The two surfaces are in contact. That is frictional force. Now, frictional force would act at every point, here and here. Every corresponding point there will be a frictional force. Yes? We will call those frictional forces F1. Let us say this body is moving towards the right with some speed v. So the frictional force at point 1 would be F1 in this direction. Here it would be F2 in this direction. Here it would be F3. Here it would be F4. So on for the number of points we can show F1, F2, F3. Every point we are showing. And similarly on this surface, by Newton's third law, corresponding contact force, there would be F1 like this, there would be F2 like this, F3, F4, etc. on this surface. Now this surface, let us say it moves, it has a displacement XA to the right. Yes. Now we are assuming that this body is a rigid body. So if this body moves by a displacement, has a displacement XA, every part on the body will have the same displacement XA. We are assuming there is only pure translation and there is no rotation. So in the case of pure translation, every particle will have the same displacement XA. Similarly, if this surface has a displacement XB, every particle will have a displacement XB. So let us apply the basic definition of work. It is the dot product of the force and the displacement. So I can say work by the frictional forces at the surface A would be F1 vector dot XA. There would be F2 vector dot XA again. So on it will go on. Now we can remove XA common and say this as the summation of F1. It is the summation of F1, F2, etc. dotted with XA. This is the total frictional force on the surface A. FA we will call it. So this will be FA dot XA. That will be the work done on the surface A. What about the surface B? Work done with the frictional forces acting on surface B would be much the same way, but here now these forces are in the opposite directions. The forces are in the opposite directions, and so therefore I will call this as say F1 dash, F2 dash, F3 dash, F4 dash. So I will say it is F1 dash dot XB plus F2 dash dot XB, so on. So this would be F1 dash plus F2 dash so on dot XB. This is nothing but the total frictional force on the surface B. We will call that as FB. The total frictional force F1 dash plus F2 dash plus F3 dash etc. We are calling that as FB. FB dot XB. That is the total work done by the frictional force on the surface B. Now we want the total work. If you want the total work by this pair FA and FB. So the total work would be WA plus WD, that is nothing but FA dot XA plus FB dot XB. Now by Newton's third law, FB is equal and opposite to FA. So I can substitute for FB and minus FA. So the total work W becomes FA dot XA plus minus FA dot XB. So FA is common here now and I get XA minus XB. Yes, FA I have removed common and XA minus goes to this XB, so XA minus XB. So this is FA dot XAB. Yes, that is the total work done by friction by the pair of frictional forces. Now, this can also be written in another way. If I put FA as I will block this. This is, I put it in a box. FA is minus FB and XAB can be put as minus XBA. Where what is XAB? Is the XAB will be the displacement of surface A with respect to surface B. And that will be, here we have minus XBA. XBA is nothing but the displacement of B with respect to A. These two will be opposite, equal and opposite. So this gives you FB dot XBA. So the total work done by the frictional force can be said as frictional force on a surface. It is the dot product of frictional force on a surface, on any one surface, on a surface, and the displacement of that surface, whichever surface you have chosen, of that surface with respect to the other surface. With respect to the other surface. That would be your. So you can either use this or this. There's no question of adding these two up. It is, we already added the total work. So this is the total work is either given in terms of frictional force on surface A or in terms of frictional force on surface B. FA and FB are equal and opposite. Yes. Now, let us say there is a block on block. There is a block here and there is a block here and we apply a force here. So we will call this a surface B, body A. This is surface A. And let us assume that these two bodies move such that there is no slip. No slip implies if the displacement of the top block is XA, the displacement of the bottom block is XB, both these are equal. That is what it means that when we say XA is equal to FB. Now, what about the frictional force? How is the frictional force going to act? If the surface is rough, obviously frictional force on A will be in this direction. Frictional force on B by Newton's third law will be opposite. That we are calling it as FB. So, if you want the work only on A, it will be FA into XA. It will be a positive quantity because FA and XA, we are assuming XA, the force is towards the right, so XB is like this, XA is also like this. So this will be a positive quantity. Whereas the force on B would be FB dot XB. This would be a negative quantity. Yes, if you add these two forces, if you add both these works, you will have FA dot XA plus FB dot XB. FB is minus FA. So FA is common and you get FA dot XA minus XB, which is nothing but FA dot XA with respect to B. But we are saying here that A does not move with respect to B. There is no slip. XA equal to XB. So this quantity is 0. So therefore, the total work done by friction is 0. Because the total work done by friction is 0, there is no heat loss in this case. Yes, you find that there is no slip. Since there is no slip, there will be no heat loss. Remember, if I put both my hands together like this and simply move them this way, I will not be able to warm my palms. My hands will not become warm. Only when I do this, my palms will get warm. So there has to be a slip between two surfaces for heat to be generated. Since we are saying there is no slip, XA equal to XB, the total work done by friction is 0 and there is no heat loss. However, the individual works are not 0. The work by FA on A is positive, work on FA of B on B is negative. Both these add up to 0. But now let us say there is slip. If there is slip, well, then we know that A must slip behind because A cannot go ahead of B because the force is being applied on B. So B and A will either move together or A will lag behind. Yes. So if that is the case, the work done, this will not be 0. The total work would be FA dot XAB. That would be the work. And let us see whether it is positive or negative. Well, we are saying that A slips. A is here. A slips behind with respect to B. B is ahead because the force is on B. So, and the frictional force on A, FA, is towards the right. So, the displacement of A with respect to B is towards the left. So, therefore, the total work by friction is going to be negative. Yes? And here there is slip and therefore there will be heat loss. The whole thing can also be seen as work is equal to FB dot XBA. FB, if you take B, the force on B, frictional force on B is towards the left. Now B is slipping towards the right with respect to A. So XBA is towards the right. So the dot product of these two will again be negative. It will give you the same value. It will give you the same value as FA dot XA dot B. It is negative here also. Yes. Let us now take a case, another similar example, where you have a block placed on a surface and there is a bullet which is shot at it horizontally. So there is a block and there is a bullet which is shot at it. So the block starts moving and there comes a time when the bullet comes to rest with respect to the block. It has penetrated fully and it is at ground and both are moving with a common velocity. Yes, both are moving with a common velocity, and we now wish to see how much will be the heat generated. The case is similar to this case of slipping. In this case, where the block on block where A was slipping behind, there would be heat generation. Similarly here there is going to be heat generation. Let us say the bullet, let us say, moves by a distance xa, has a displacement xa. Let us say the block has a displacement of xb. So the work done by both the frictional forces, yes, if I show you the frictional forces on the bullet the frictional force is going to be opposite to the direction of slip. It is slipping ahead, it is slipping towards the right. So frictional force will be this way, and by Newton's third law, frictional force on the block would be like this. So if you consider one by one, work on the bullet, work by friction on the bullet would be Fa dot Xa. It's going to be negative because Xa is positive, Xa is towards the right and Fa is towards the left. So this is going to be negative. Work done on the block would be Fb dot Xb. Fb dot Xb. Fb and Xb are both towards the right, so it's going to be positive. What is the total work? The total work, if you add, let us substitute for Fb as minus Fa. So this would be Fa into Xa minus Xb. The same result what we saw, dot product. So this will be Fa dot Xa with respect to B. A with respect to B, this is the displacement D. Yes, it is towards the right. The bullet has moved to the right with respect to the block. So this will be Fa into D into minus 1, because D and Fa will be cos of 180. Cos of 180. So that will be the total work done. D is the depth of penetration of the bullet into the block. That will be the heat generated due to both the frictional forces, due to the pair of frictional forces, and the work done is negative. Friction does negative work, so therefore the kinetic energy of the bullet and the block will decrease. That decrease in kinetic energy manifests as heat. Let us take another example. This is the case of a block on a wedge. A wedge, unlike an inclined plane, can move. Supposing we have a wedge like that and we place the block on it like that. Well, the block will no doubt come down, but the wedge will also move towards the left. What is the reason for that? If you draw the free body diagram for the wedge, there will be a normal force N by the block on the wedge. On the block also there will be a normal force by the wedge on the block. Now this N will have a horizontal component. That horizontal component moves the wedge. Now let us say the surface is rough. So if you now see, the block will have a displacement, let us say x dash, with respect to the wedge. The wedge moves by a distance xa, xb we will call it, we will call that as b, xb, and therefore the absolute displacement of the block is going to be XA, like that. If this angle is theta, this angle will also be theta. Now let us see the frictional forces. On the block, the frictional force, since it is coming down, it is slipping downwards, will be upwards. On the wedge, FB would be downwards. So let us now again calculate the work done by the frictional forces. Work done on A would be FA dot XA. FA, XA is the absolute displacement of the block, so it will be FA dot XA. Work done on D, that is a wedge, would be FB dot XB. So the total work, you add up these two, you have FA dot XA, and instead of FB we are going to put minus FA, because FA and FB are equal and opposite by Newton's third law, into XB. So FA would be common and you would have XA minus XB. So that would be FA dot XA with respect to B. That would be the total work done by friction, by the pair of frictional forces. Now if the displacement is x dash here like this, see the frictional force XAB, XA dash, x dash is nothing but XA with respect to B. So now we know FA is upwards. FA is upwards. So this would be FA, XAB is x dash, and you will have cos of 180. So the work done, overall work done by friction is negative, and hence again there will be heat loss because there is slipping. Thank you.